Kura. Hello, I'm Patrick Howell here to present our IP image processing part of our semester project. And I'm Patrick Howell.
And I'm Lisa.
And we'll start off with the main function, the int main, where we have the size of our window set up to 1024 times 768. And we also have our problem statement. Note that it is the IP image processing problem statement and not our actual project problem statement. And it states how can we make a feedback system for our game which is physically implemented but only accessible to active players. And with this we'll get started.
So we have this test app H where we have the basic functions and basic variables. We have names. We have the setup, update, and draw that we'll use later, and then we have the key press track rectangle that we also will mention later. Like it listens for a key being pressed and a function that tracks the rectangle. Then we include the of width grabber and the of texture, and also we include the image of the clown that will appear later. Also, we declare an unsigned char for RGB, which also will be used later in the test app.cpp, which we'll go to now.
Alright, so as we see here, we set up the cam width and height, which is the actual sizing of what our camera will see, and the actual quality of what the camera will see. We set up a boolean called Atom, and we set it by default to false at the beginning of our program. We set the vid grabber to set verbose. We use this so we can get a more detailed debugging of our program throughout the development of it. So at this point in time, it could arguably be removed, but we chose to keep it just to show what we did earlier on. Vid grabber init grabber is our initializer for the vid grabber, and pretty much just sets the whole thing on the tracks of getting started. And we have our color image, the unsigned char, in which we set up the cam width and height and the 3 color dimensions included. We have the video texture allocated so that we basically make room for what we're about to make and set off memory for this program. And lastly, we load the clown image into here. And now I'll move on and leave Fire with the word.
This is a function called update that is the first function that will run after the setup. It updates the necessary variables and whatever is in it in order to make the program running correctly. We have the width grabber grab frame to get new data for the sequence grabber, and then we have the width grabber is frame new. It's just a tool that we use, which when activated, when true, does this. We use the unsigned char pointer pixels and set it equal to video grabber get pixel, which gets pixel for us. In order to do that, we have the 3-dimensional. We have a triple for loop that converts the input to output in color. It runs through horizontal and vertical, and then checks the colors also. Then it uploads the pixel in a RGB array into the already allocated texture in memory.
Alright, and next we have our draw function, in which we set the background to 255 times, well, 255 in all the color dimensions, meaning that it'll be a white background. We set the texture to be drawn in the coordinate 0.0, meaning that it will be initialized in the upper left corner of the screen, or the window that we'll be opening. Pardon me. And we'll set the previously mentioned Atom boolean into context, remembering that at this point it remains false. However, all these things that we'll be explaining now will be triggered when it is set to true. So first we have the track rectangle, which basically tracks where our lines will be forming into the rectangle that we want to obtain with our 4 different colors, red, green, blue, and yellow. And we have the no fill function that ensures the center of our circle around the aimed point being transparent, meaning that if we're aiming at the red, there'll be an outline of red around it, much like an aim in a given video game, video game. And also we have the line thickness set to 4 pixels in the set line width. And as I just mentioned, down here we see the set, offset color and off circle, setting the color of the circle around our aim and the position to be 40 in diameters, 40 pixels in diameters, and the color red by setting it to 0, 0, 200. This structure continues down throughout all the 4 colors, being actually set red. This one I believe is blue, as well as the others. Yeah, red and green and yellow. So moving on, we set the offset color, which means the let's see here, effect. Oh, we set the line color to black, basically so that the lines that will spawn in between each of the points that we find will be black. We set the poly mode function so as to control the behavior of the shape. I'll have to ask Fire here.
Oh yeah, true. Poly mode controls the behavior of the shape in order to make it work the way that we wish.
Yes. And then we have the begin shape, which basically initializes the line from a given point, one of the 4 points that we have. Moving over to the end shape, making sure that it actually ends when it reaches its opposing point. And in between we have the various 4 points in the shape that we want to use as the origin of each line beginning. And finally we have the clown draw set at the same location as our red in this function. However, it will not be demonstrated, I believe, at some point. Oh, it will in this version. Pardon. In this version, we will actually have the clown spawned in our program, as to illustrate what we initially wanted to aim for when having our scoreboard drawn within our rectangle. And lastly, we have the initializer of the program. We have a key press function listening to when the program needs to be started. By having it assigned to G, we can actually control when to start the program. So when we start the program, when we open the window showing what the webcam sees, no program concerning the rectangle and the 4 points tracking won't be initialized until we press G.
The webcam input is equal to the output.
Exactly. And so at this point we set Atom to true, triggering the perimeters that we've set up earlier. And now I will take it away.
Then we have the track rectangle function here. It's mentioned earlier that it tracks the rectangle, just in case you forgot. It is set to the position 0.0. It's the circles. If it finds no pixel that fits to the color values that we have set for it later on, then it is spawned at point x equals 0 and y equals 0. The int n, called n, is the number of pixels found that matches this color value that we also will explain later. Still, this is also still the pointer to get pixels, and we use here a double for loop that runs through a 2D array, which is the input from the camera, and then it checks if this is true, if there is any red, green, or blue pixels in it. And it's here that we set the RGB integers to be something. It has a value now. Okay, and now we have the result 2, 3, and 4, which is each blue, red, black, and green. This means that it detects in this 2D array if there are any of these pixels, and this is an if statement using the ternary operator, this one. If this is true, it is set to 255, which is white. And if not, it is set to black. It could as well have been a boolean and just been true or false. So in this interval, if there's any pixel which is this color, it is set to this, which triggers this if statement that it adds the position together. It means that if there are more pixels this color, it adds all of the positions together. This will have a very high amount if there are a lot of pixels, and we'll come back to that solution later. The number of pixels here are also added together in order to use it later. So down here we use it, and the number of pixels, if it is more than 0, then we divide the position that we have added up to the number of pixels. And that means that we will have the circle that spawns in the center of all the pixels that we've got. And that's about it. And now we'll run the program and test it for you.
Alright then. So now reaching the part where we have less divided, assigned speaking parts, if you will. We'll just pretty much take it as a casual go. So if you'll put that up, notice that we initialize the program, and there it goes. Now, if we try to turn the whole thing, no, it won't help me turn it. Well, initially the idea was that the clown would be assigned to the blue here, showing that it could be inside the rectangle. Now, the most troublesome part of this would be for the clown picture or the given uploaded picture to actually fill out the entire rectangle and customize itself to fit the shape. This is something that we're still working on. So that's pretty much the basics of it.
Yeah.
And as you can see, the aims, the 4 various aims or circles, are tracking and positioning themselves over the majority of the color that they're tracking. So I guess that's it from me.
Well, yeah, you explained that an image would spawn in the middle.
Mm-hmm.
Yeah, good. Yeah.
So that's it.
Thank you for this.